has one that's out of order. So chromium here has one that's S1 and D5 when it really should be 2 and 4. Copper is S1 and D10 when it really should be 2 and 9 there. What's up with that? Well, maybe we'll talk about that in a later lesson, but like a lot of things in science, you come up with a rule and then there are always exceptions to that rule. No, you won't have to know any of those exceptions. So here are the types of questions that you're probably going to be asked about these things. You're just going to be asked about the electron notation for these things. So this one here says, what is the full electron notation for aluminum? All right, well, let's find aluminum. There's aluminum right there. So if we are going to go and we are going to do aluminum, all we have to do is make sure that we hit every electron from 1 all the way up to number 13 there, and we make sure that we hit them in the right order, and we make sure that we get the correct shell, subshell designations for them, and then we're in good shape. So this one here is where we always start. We always start with 1s2. That's numbers 1 and 2. Then we have numbers 3 and 4. These guys over here. Remember, they are in the second row. That's the first row. These guys here are in the second row. They are in the S subshell because, again, everything in this guy here is the S subshell. And there are 2 of them that are there. So this is going to be second row, S subshell, 2 electrons. Now, our next ones are these guys that are over here. Well, remember, everybody over here is in the P subsection. But we are still in the second row here. So, consequently, those electrons there are in the second row, P subsection, and there are 1, 2, 3, 4, 5, 6 of them. So we got to do 6, 2p6. Now we come back over to those guys. Well, they are in the third row. They are in the S subsection, and there are 2 of them, so that's 3s2. And now finally we get to our last final outside highest energy ground state electron, and that is that guy there. He is in the third row. He is in the P subsection, but there's only 1 of them there, so it's 3p1. So the full electron notation for aluminum is 1s2, 2s2, 2p6, 3s2, 3p1 there. Now, one of the things that you can do to shorten it up is you can do what's called the noble gas or the abbreviated electron notation. So this is sometimes called the noble gas notation. So all you do on the noble gas notation is you just do a little shortcut, because remember, the whole point of the noble gases is that they are stable. So they kind of give you a safety zone. So if you're trying to get to aluminum, the first safety zone that it hits is helium, and then the next safety zone that it hits is neon, and then it's not going to get past neon to argon here because we stop at number 13, which is aluminum here. So the electrons that are in this shell are pretty stable. That's what I mean by a safety zone. Those electrons are stable. It would take a lot of energy to disrupt those electrons, and they're typically not disrupted. And the same with these 8 electrons. Once you get all the way over to neon, those are in a stable full shell. They have a stable octet. So consequently, they're typically not messed with. So if they are not messed with, then what we can do is we can start right here at neon and then just go all the way from there. So neon is where we're going to start. And then all we have to do is do that one, and number 13 there, and we're done. So this is, again, 3, and then that's S. So this is 3s2. And then this one here is the third row P subsection with number 1. So that's 3p and 1. So again, our full notation is 1s2, 2s2, 2p6, 3s2, 3p1. But this all the way up to this is 2, 4, 10 electrons, and 10 electrons is the neon. So we're just going to go ahead and start by giving us a boost up. We're just going to cheat a little bit, and we're going to start here at neon and then just do everything past that. So if you are asked for the abbreviated, or if you're asked for the noble gas notation, then you can do it the cheap and easy short way. Let's look at another one. This guy here says, what is the full electron notation for barium here? Barium. Oh, ugh, yeah. All right, fine. There's 56 of them. So we're going to start here. That's going to be 1s2. Then we're going to go all the way to here. And that's going to be 2s2 and 2p6 for 2s2 and 2p6. And then we're going to do those guys there, and that's going to be 3s2 and 3p6. Again, those guys are your 3s2, 3 and s, and there's 2 of them. That's the 3, and then that's the p subsection, and there are 6 of them. All right. Now we get to those guys. Those are our next one. That's our 4s2. And then we have the only weird ones of the bunch here, which are these D ones. Remember that the D's are always one less than they should be. Those are in the 4th row, but remember that section there is going to be the 3D section. So that's going to be 3D10. And now we're looking here at those guys. Again, we're back up to the 4th row, P subsection with 6. Oh, this is so long. I have to shrink this guy down. Now we're going to look at this guy here. That is the 5th energy level, the S subsection, so that's 5s2. And now we got to go to here, those guys. It is in the 5th row, but it's the D subsection, so it's 4d10. And then we're going to go back up to the main group elements in row 5, so that's 5p6, almost there. And then finally our last 2 here in level or shell 6 is 6s2. So the full notation for barium, all 56 electrons, looks like that. The abbreviated or the noble gas configuration for barium is considerably shorter, because all we have to do is pick one of those noble gases, whichever one is closest to barium. We cannot do radon because we haven't gotten up there yet. Barium is number 56, radon is number 86, so we haven't reached 86 yet, but we did reach 54. So if that's the case, then we're just going to put a bracket and put xenon and start there at 54, and then all we have to do is that, and then that's going to be 6s2, and we are done. So everything from here all the way up to here, all of that is what xenon's arrangement looks like. So the abbreviated version is far more desirable once you get to the point of these large elements. Last one here. It says, what's the full electron notation for iodine? Oh, fine, another big one. All right, we got 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. That takes us to calcium. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So that's there. Now the only goofy ones are these D's, which is why we're at the 3d10. And now we're back up to normal with those guys with a 4p6. So that is our first D subshell. Don't forget that the D's are always one less. So now we are all the way to here. So that's going to be a 5s2. Now we're going to go with those guys. So that's going to be a 4d10. And then finally we're going to go with those guys. Main group back up to normal. That's going to be 5p5. If we are going to make this into a noble gas, I don't want to start all the way over again. I'm just going to go ahead and copy and paste here. All I'm going to do is start at the nearest preceding noble gas to all of this nonsense, which is krypton, number 36. And that is in the 4th row in the P subsection, and it is number 6. So all of that, everything up to 4p6 is what krypton is. So I'm going to erase everything from here, and then I'm going to do krypton like so. All right, one last one real quick. Can you tell me what's wrong with this? 1s2, 2s2, 2p6, 3s1, 3p4. Well, at first glance, it doesn't look like anything's wrong, but when you look at it, again, we've got the 1s2 that's there. Okay, that's normal. Let's go back up to this guy so we can check it out. 1s2 is normal. That's those guys, so that's nothing to worry about. And then our next one is 2s2. Okay, that's fine. That's our next one's there. Again, we did him and him already. And then our next one is 2p6. 2p6, that's normal. Nothing appears to be wrong so far. And now 3s1. Okay, that's fine. 3s1 is there. And now finally 3p4. Well, wait a minute. That doesn't seem right. 1, 2, 3, 4. What's up with this guy? We have skipped this guy. Well, if that's the case and you skip an electron, that means one or more electrons are what's called being in an excited state. And if they are in an excited state, one or more electrons has been jumped up to a higher level than it should. Or in other words, it's out of order. So if you notice that something is simply out of order, that means an electron is in an excited state and somebody has put some energy in, and wherever that one electron was that got skipped, that one electron has then now been moved up to some other place, because in reality, if we look at the correct number of electrons, this guy here and this guy here should be, come on, that guy here should be back down there, because it should be S2P3. That's where he should be. So it should be S2P3 if it was in the ground state. And again, the ground state